Today's lesson is going to be about ratios. The word ratio looks very similar to the word rate. R-A-T is in both words, and they are very closely related to each other, and sometimes it's very, very similar to solving a ratio and a rate. Ratios, like rates, they compare things, but with a ratio it's more comparing within the same unit, where a rate can be two different units being compared to each other, such as miles to hours. Miles per hour is a rate that's very common. With ratios, let's say for instance students, 6th grade students to be more specific. So we could compare the girls to the boys in the 6th grade class. That would be comparing students, that unit, but within that unit we're comparing the girls to the boys. So that could be a ratio then instead of what we would be considered as a rate with miles per hour. So when we look at that ratio, we're going to do the very same thing in solving it as we did with rates. We're going to use a rate format. And remember, the rate format are two equivalent fractions that are going to be solved by cross multiplying. And so the ratio is usually what we try to solve as a fractional look, and then we're going to know something about what we want to solve as a third number with a variable or unknown as the other numerator or denominator. Again, having labels is very, very important with doing ratios as we do with rates. So we're going to set some examples up here so we can compare and see maybe the difference between a ratio and a rate. And a lot of times it looks like the same thing. So a lot of times it's a good example of thinking about a deck of cards. Either you see them face up or they're turned upside down or face down, we call that. So let's think of, we have two face cards and we have three cards face down. In this example, I would be comparing these cards, my unit, but some are face up, some are face down. So in my ratio, I can say I have two face up cards and I have three face down cards. So my labels, I always want to make sure they're there with what I'm talking about in my problem. So two face cards, three face cards down. And then I can say this as 2 to 3. And that's a lot of times you see ratios with this colon between them. So this is a ratio of two face cards to two face down. And when I do that, I again convert that into a fraction, and just from horizontal to vertical, I get that. So this would say for every two face cards up, there are three face down. So if I saw it in words, this as symbol writing would look like this in words. Here's some very key words. For every two face up, I have three face down. That is key on building my rate format. That word, that vocabulary in a problem with a ratio. For every means I'm comparing the 2 to the 3. There is no total. Notice I don't have total here, like normally our denominators mean total when we're doing some type of fraction work. But that's not the case here. It's just one compared to the other of the deck of cards. So the problem could be, okay, let's take for every two face-up cards, there are three face-down cards. Now I want to say, well, what if I have 6 face-down cards? How many will be face up. Now again, this is a very simple problem. A lot of you'd say right away, oh, you know, I know that answer because of equivalent fractions. And you're right, but again, to solve this problem, what is it telling me? So for 2 cards that are up, 3 are face down. What if I have 6 cards face down? I put that 6 at the same level as the 3 down, and then I can solve the question, how many are face up? So then there's my unknown, my variable goes here, and I cross multiply and get the answer of 4 cards. So 2 times 6 divided by 3 is 4. So my equivalent fractions are there again. 2/3 and 4/6 are equivalent. But as we get into more difficult problems, these labels are so important because they're going to throw some tricky different questions into these problems. And as long as you build things correctly, you'll be fine. So pictures help too. I have 2 face up, 3 face down. Draw it out. It can help you visualize what they're asking you to build that ratio. So in this case, for every means I'm comparing within the unit 2 to 3. Now, the next type of problem that can work the same way, it's still a ratio, but the wording or the questions can be different. So what if I have the very same cards, 2 face up, 3 face down, but the question is 2 out of 5 cards are face up. Now, what is this telling me? The 3's gone, but now I have this 5. So here's my key words here in this problem with this ratio. 2 out of 5. I'm talking about totals. So when I would build that, and I didn't have a drawing, let's say there originally, I know there's 2 face up. Well, how many are face down is by the total. I know I need 5 total. So that must mean then to get to 5, 3 more need to be added. So that's my face down cards. So I can have a problem that looks like this, and I can still label 2 face up, but this is not face down now. This is total cards. And I can have problems like that that are going to ask me total amounts. Well, I don't want the face down number, but could I still get there? Yes, because 2 and 3 that was there originally, how many total cards would I have? That would be the 5 that I could still use. So there are some different strategies that we'll talk about as we do these problems in class and practice. But this one, if I know I want a total, well then use that as your denominator and you can get there quicker. I could have probably got there okay with 2 out of 3 yet, but having that is important maybe for the problem that would say I have a total of, let's say, 10 cards. Let's do it this way. I have a total of 10 let's try to make this maybe a little more understanding of some of the problems you're going to have. I have added 5 more cards. Now you have to think through this maybe a little bit more. I have added 5 more cards with the same ratio. How many are up or face up? Okay, so what information do I have to fill this rate format in so I can solve this? Well, if I add 5 more cards, 5 plus 5 is 10, goes here. I want to know, again, face up. That's what I'm trying to find, the unknown. So again, if I take the information I know, build it into my rate format, I can then solve this. So 2 times 10 is 20 divided by 5. So 4 would become in. So this answer would be, then I have 4 face-up cards now. Again, I kept it simple. And some of you with Math Sense would get there without that rate format, but they're going to become more complicated. So build this correctly with my labels, and I can always solve the problem no matter what it is. So 4 cards are now face-up, where it was 2 before, but the ratio is still 2 to 3. And I know that because of my totals. What's left after 5 if I take 2 away is 3. So it's still a 2 to 3 ratio. It's 2 out of 5 cards, but the ratio is 2 to 3. And I always can find that if I know the total and I know one of the other numbers to compare to. I just can subtract them and I get the ratio. So the ratio sometimes is shown this way, 2 out of something, or for every, remember that vocabulary, for every, then that's comparing the two, and then the total is adding them up. This case, the total is 0. And then again, if I'm comparing two things like the previous problem, face up, face down, I can do those as labels and solve a problem, or I can take one of them that's being compared to the total of them, and it can also solve problems that way. So it really works good of knowing out of means total, for every means I'm going to have the two comparisons. So let's try one. There's a couple in our journal that I'm going to use as examples here in the video, and then that page is going to be on 302. So if you do have your journal, or if your journal's still at school, I'm going to work 2 of those problems in this video, and then the rest of them we'll do together in class or as a small group practice at our next class. So it says, and I'm going to put my rate format right here because that's my tool to get to the answer. And it says a spinner lands on blue 4 times for every 6 times. So spinner lands on blue 4 times for every 6 times it lands on green. Do I have a ratio? Think about this. We're comparing colors. There's my unit, but within the colors I have blue and green being compared to each other. So I can start building this with what I know. Maybe it's not the right format when I'm done, but I can experiment. So let's see. The spinner lands on blue. Oh, there's a label. Blue is going to be one of my labels. And green is that other color, so I might as well label that. Can I have green on top? Sure. Blue on the bottom. It doesn't matter as long as my numbers go with those colors or labels. So how many times is it going to land on blue? 4. And for every, so now I'm comparing the two. There's my key words. So for every time it lands on blue, 6 times it lands on green, for 4 times on blue. So there's my ratio. How could I write that? Remember, it could look like this, 4 to 6, and that's another way of writing it. And so I have my 4 to 6, green and blue. The rest of the problem says now, how many times does it land on green if it lands on blue 12 times? So I want to find green, so I might as well put that there as my label. And blue says it's going to land, blue is 12 times it lands on. So I'm just going to abbreviate the problem. And so blue is 12 times. So that's what I'm going to compare. So blue, here's my blue up here, so the 12 is going to go there. So now when I solve this, I have a ratio yet that's 4 to 6, but it's going to have 12 to something as I spin more times. That's what this problem would say. Okay, I've spun it how many total times? Add those up. 10 times it's spun, 4 times it landed on blue, 6 times it landed on green. There's my ratio. But total, I add those up. If it's a for every, it's comparing the two numbers. But total is there, 4 and 6. Well then, if I spin it a bunch more, now I've spun it 12 times, or I've spun it, and 12 of those times it landed on blue. Well, how many times did it land on green if it's the same ratio? Well, I cross multiply. 6 times 12 is, got it, 72. And 72 then divided by 4. We'll do the math here. Whoops. It sure isn't 3 times 4 is 7. I have 1 times 4. And if I subtract that off, 4 goes into 32 18 times. So my answer for here is 18 times would land on green. So if it landed on blue 12 times, and it's the same ratio, 18 of those times it would have landed on green. What's the total spins I did then? If 12 is blue, green is 18, add them up. And that would be, in other words, 30 spins I did to get these totals. I did 10 spins here and got that ratio. Well, now I did it 3 times more, 30 spins, and I got the 12 to 18 because it was the same ratio. Not necessarily would it ever be that way, because it's random again, probability we just did in the last unit. But if I said it was going to be the same ratio, this is how we'd figure that out. And it could have told us, we're going to spin the spinner 30 times and it's going to be the same ratio. Well, then I could have put a 10 here, and if I knew 12 and 4 were my relationship, I could have found this number then by the total, put a 30 here, and then I would have figured out that this number is going to be 12. So if I knew this was 10 and put 30 here because there's 30 spins, if that was the question, then I could have changed this to totals and I would have found 12 compared to the 4. Or I could have done the 6 up here as the green and I would have found 18. So to work those problems, we'll do more of those. I don't want to take the video time to do that, but it's very, very possible to find different questions that it's asking by building that rate format correctly. Okay, so we'll do one more here on the video, and then we'll have time to practice in class. It rained 2 out of 5 days in the month of April. 2 out of 5 days was rain in April. Oh, we need some previous information here to solve this. And we sort of had a question on a math box a while back about April's days, of how many days there are. So we're going to need to know that information. It's not going to give it to us here, but we'll provide that. The question is, how many days did it rain that month? So how many days did it rain? Well, we have a ratio going here, but it's sort of like a rate because we have totals going on. But it's still a ratio because I'm comparing 2 out of total of 5 days as the ratio of that month of April it rained. So how many days didn't it rain in those 5 days would be 3. So I could build a ratio 2 out of 2 compared to 3 days it rained in April, or 2, or for every 2 days, that for every 2 days it rained, 3 days it didn't. So there I have that comparison of days, 2 to 3, but you can also build it this way, 2 out of 5, and I know the 3 days it didn't rain. So my rate format, I'm going to have the 2 and 5, but my labels here become total because of the out of vocabulary. And what is this? These are the rain days, 2 of them. So I have that rate format going, and now what is it I want to find out? I like to do this because then I can put my variable in it. So how many days did it rain? Oh, rainy days. There's my variable, my unknown. Well, what is this that isn't in this vocabulary or text? That's where I said previous knowledge we needed. So how many days total are in April? And that is, if you all remember, is 30. So that information would have to be previous knowledge or given to you because it wasn't written there. So now I have this problem of total days, 30 days of the month out of the 5 days in the ratio, 2 are rainy, and now I can find my answer. So 2 times 30 is 60. 60 divided by 5 is 12. So 12 days it rained in the month of April with the ratio that 2 out of 5 of them were rainy days. So then I can find, okay, that means 12 out of the month of April, 30 days, it was some type of a rainy day. How many days didn't it rain? That could have been the question. Well, then what would I have done if it said, well, how many days didn't it rain? Well, all I would have done here was change my labels and said, well, 2 out of 5 rained. Well, that means 3 didn't. And not rain would become my label here. And I could have said, well, 3 times 30 is 90. 90 divided by 5 is 18. So 18 days it didn't rain. So it could have been depended on what the question was asking. So be prepared to always read what it's asking you, because that will be the key to building your rate right. Now, I could have found that answer by still doing the same ratio and rate as I did before, because 12 days were rainy. Well, out of 30 days, could I subtract 12 from 30 and got the 18? Sure. So there again, we keep emphasizing that there are always different ways that we can get to answers. But in class, we're going to try to show those and share those ideas, because someone might see it easier one way versus another. So as you do ratios, oh, I got rid of the word ratio up here from my erasing. So as we do ratios, it is similar to rates, but yet there are some differences with it, with the comparison within a unit. So this one is sort of totals, out of, we're going to have totals in my rate format. When it says for every, then it's comparing the two. There's no total there. And then we're trying to get a comparison of a different size or an amount. So do your best, and if you don't have your journals, we'll come to class and work with ratios.